This workshop is the second of two workshops about data visualization tools. In the first workshop, we primarily surveyed the different kinds of online data visualizations that have emerged in the last 10 years or so. I've created a portfolio of those different kinds of data visualizations, which you can access at bit.ly/Morton-DV. In this second workshop, we're going to take a more hands-on approach and learn how to use two kinds of data visualization tools. First, there are data visualization tools that already contain indicators. That is, they already have data that has been acquired from various sources, but they allow you to manipulate and explore that data. Gapminder is one such tool. Second, there are data visualization tools that don't contain data until you provide it to them. That is, you gather, organize, and upload your own data, and then you manipulate and explore it using these tools. Google Motion Charts is one such tool. Let's start by having a look at the first kind of visualization tool, the one that comes preloaded with data. As I mentioned, Gapminder is one such tool, and it's available at www.gapminder.org. Now, when you first go to the Gapminder website, you need to click on this button that says Load Gapminder World in order to get to the actual tool, and it will load a set of default indicators. Collectively, they're known as Wealth and Health of Nations, and you can see why. Over here on the vertical axis, we have life expectancy, so health, and on the horizontal axis, we have income per person adjusted for inflation, so that's the wealth aspect of things. Those two indicators are the kinds of things that you would expect to find on the traditional paper-based graph. Those paper-based graphs can only depict up to two indicators simultaneously. The thing about a tool like Gapminder, though, is it can depict up to 5 simultaneously, not just the two axes here, but also if we look at what's on the graph itself, we see a number of bubbles, and those bubbles have at least two characteristics. One is size and one is color. The size of them corresponds in this case to the population of the country in question. So here's India, big population, big bubble. Here's China, same thing. Here's Angola, small population, small bubble. Now the size of the bubble, though, does not have to correspond just to size, just to population. We can, for example, go down here to the bottom right and click on Indicators, and we could select Child Mortality. Takes a minute to load, and now the size of the bubbles corresponds to child mortality. Okay, let's go back to population. Let's go to male by age. 10 to 14. Okay, so we're loading that indicator again. It's not the one that it defaulted to, it's different, but for our purposes this is fine. Color is another characteristic that these bubbles have, and the color corresponds to the geographic region to which the countries belong. So anything that is blue corresponds to sub-Saharan Africa. Anything that is red corresponds to East Asia and Pacific, and so on. But again, the color does not have to just correspond to geographic regions. You can select another indicator down here. Let's go back to the child mortality again. And you'll see that they're now different colors. And the ones that are blue, that means that they have a very, let's see, they're down at this end of the spectrum with regard to child mortality. The ones that are sort of, what is that color? Apricot color, are at the higher end of the child mortality spectrum. Okay, what else do we have here? Oh yeah, the scales can be changed. Currently, this axis is linear. We can change it to logarithmic. We can change this one from logarithmic to linear. Have them both linear. Have them both logarithmic. Oh, and the other indicator too is simply the dimension of time. So we will move this bar back to 1950. We begin to play it, and the bubbles move as life expectancy and income per person change over time. Now you can also do things like this. You can highlight some of the items, or nations in this case, in order to make them stand out a little more. And as well, now that they are highlighted or selected, when I click play, you'll see, there we are, you'll see that the trail of the selected items is also captured. You can see it best with Afghanistan here. Probably if I change the scale again, it would be more clear. But in any event, the trail or the track of the items is captured so that you can see it. It persists throughout the visualization. You can also, if you want to make the opacity of the non-selected items less, you can move this bar down to the left and they become basically transparent, or you can move it to the right and they become very opaque. We'll leave it somewhere in the middle. Another thing you can do is, if you click this little arrow in the corner here, this allows you to zoom in on a certain part of the graph. So I will select the plus magnifying glass here, and let's say we want to focus on this, and that will zoom us in on those elements, Singapore and United States and Kuwait, etc. If I want to go back to the default, I simply press 100. Okay, I think those are the main features of Gapminder, the tool. A couple things to remember. One is that it allows you to depict or visualize up to 5 indicators simultaneously, as opposed to the 2 indicators associated with more traditional graphs. The other thing is that the data is already in Gapminder. Gapminder has acquired that data from institutions and universities, and the great thing about that is that it's been vetted, and there is lots of data there, hundreds of different indicators that you can use or play around with. The downside, though, is that you can't upload your own data as an instructor or researcher, but there is a tool that allows you to do that and allows you to create motion charts very similar to what you see here in Gapminder. And in fact, it's called Google Motion Charts, and that's what we're going to move on to next. Now, the first thing I want to point out about Google Motion Charts is that the final product that you can make with that tool looks very much like what we saw with Gapminder. Essentially, you can display, as with Gapminder, 5 different indicators simultaneously. So we have, over here on the left side, the vertical axis, and down here the horizontal axis, and then within the graph itself we have the bubbles, and again color can represent an indicator, the size of the bubble can represent another indicator, and then down at the bottom we have the 5th indicator, the dimension of time, and we can play it once we click play there. You can also change the indicator that is associated with color, just as you could with Gapminder. And you can also do that with size. You can change it to any of the other indicators that you might have represented in your data. You can also select particular items in your data, and the labels then appear, making them more obvious. And now if you click play, also just as in Gapminder, the paths or the trajectories of the items that you have selected are persistent now. If you click the little wrench icon down here in the bottom right, you can also change the opacity of the non-selected items, just as in Gapminder. And you can also change the scales from linear to logarithmic and vice versa. I think the only thing that you can't do in Google Motion Charts, which you can do in Gapminder, is zoom in on a particular part or section of the graph. But other than that, it is essentially identical to Gapminder, with, of course, as I mentioned, the exception that you have to supply the data for this. I'd like to proceed now by demonstrating how to turn your raw data into a Google Motion chart. To do this, I've come up with a research question that will demand that I collect some real data. I'll tell you what that research question is in a minute, but first I want to tell you what got me thinking about the research question. It was this. I want you to say out loud what this is a photo of. Most of you, I bet, said that it was bacon and eggs. A few of you, but not many, probably said eggs and bacon. In other words, when those two terms appear together, there tends to be a favored or conventional sequence, namely bacon and eggs. A lot of food pairings are like this. We tend to say peanut butter and jam rather than jam and peanut butter, and we tend to say salt and pepper, not pepper and salt, and so on. This is true, too, for word pairings that have nothing to do with food. For example, we tend to say or write men and women more often than we say or write women and men. How can we demonstrate this? Well, just do a Google search for those two word pairings and see how many matches appear for each one. As you can see, the phrase men and women appears on the web more than 10 times as often as women and men. That's the current ratio for those two word pairs, but how has that ratio changed over the last 100 years? And in fact, that's the research question that I want to pose. To what extent have gendered word pairs changed since 1900 with regard to the frequency of one sequence versus another sequence? To get the data that's needed to answer this question, I turned to ProQuest's Historical Newspapers database, and then I searched for the phrase men and women in the New York Times for every decade of the 20th century. I then did the same thing for the phrase women and men. Once I had this data, I put it into a spreadsheet. I could have used Excel to do this, but it was easier to use the spreadsheet that's built into the Google Docs suite. After the preliminary data was in the Google Docs spreadsheet, it looked like this. What's important to note here is that the first column in your spreadsheet must contain the names of the entities that you are graphing. For example, in the Gapminder example that we looked at, the entities were the names of the countries. Next, note that the second column must contain the date information, the timeline information. For example, the year 1967. The third column contains the data that will be mapped along the x-axis. The fourth column contains the data that will be mapped along the y-axis. And that's the minimum data that you must supply in order to get the Google Motion chart to work. But you can also include two more indicators by adding data to the fifth and sixth columns. The fifth column can contain data that will determine the color of the bubble, and the sixth column can contain data that will determine the size of the bubble. The data for my research question only pertains to 3 indicators, so I don't have a fifth and sixth column. Here, though, just by way of example, is a spreadsheet that does make use of all 5 indicators. Now, at this point, I have enough data that I could begin to generate my motion chart. However, I should probably tweak my data first. After all, the size of the New York Times, in terms of its number of pages in every issue and the amount of text it contains, wasn't constant throughout the 20th century. Essentially, it started small and grew larger through the 1910s, 1920s, and 30s, up until the Second World War, when it shrank somewhat in size. It then grew larger again up until the 1970s, when the emergence of other newspapers took some of the market of the New York Times. It then plummeted through the late 1990s and in the first decade of the 20th century due to the appearance of online news media. To measure this shifting size of the New York Times, I again searched that newspaper's historical database decade by decade, but this time I searched for what I call stop words. That is, words without semantic meaning, function words, like the word the and the word of and the word or. These words, I'm assuming, change in frequency only if the size of the newspaper, in terms of the number of words it contains, increases or decreases. So here's the frequency of those stop words by decade. If we graph these stop words, we can indeed see how the size of the New York Times changed through the last century. I then averaged those stop words, and I then calculated what multiplier was needed to adjust each decade to make it correspond to the average. I then used those same multipliers to adjust the data pertaining to the men and women / women and men sequences. And once we got rid of the non-adjusted data that we don't need anymore, we're left with just this adjusted data. I then repeated all of the foregoing process for another pair of gendered words that manifests two possible sequences, namely mother and father versus father and mother. Interestingly, a quick glance at the data for these phrases reveals that the phrase father and mother was 4 times as common as mother and father in the early 20th century, but by the end of the 20th century this had reversed, and mother and father had become about twice as common as father and mother. And you'll see this in the motion chart once we generate it, which is what we're now going to do. Rendering the data as a Google motion chart is pretty easy. You simply highlight the columns that you want to include in the visualization, and then you go up to Insert, and then you select Gadget, and then you select Motion Chart, which will be one of the options that will appear. Add to Spreadsheet, we select that. We can give it a title if we want, and then we press Apply and Close, and the chart is generated. We can make it a bit larger if we want, and let's give unique colors to the two entities. Let's select them both so that their labels appear. Let's change the scales to logarithmic. There. And I'm going to play this in a minute, but first, just bear in mind that I've defined the dominant sequence of these gendered pairs as the one that is currently, like right now, favored. So for the men/women pair, the dominant sequence is the phrase men and women. And for the mother/father pair, the dominant sequence at present is the phrase mother and father. But, like I mentioned before, 100 years ago, the dominant sequence for the latter pair was actually father and mother. Okay, so now let's play this. Okay, so as you just saw, the green bubble for the mother/father gendered pair plummets as the decades roll by, because father and mother, which is currently the non-dominant sequence, becomes less frequent over time, and then the green bubble begins to move to the right as the sequence mother and father becomes more frequent. As for the movement of the blue bubble, I'll leave that for you to puzzle over. Actually, though, the complex movement of the blue bubble prompts a good question. Namely, when should you use a motion chart? You now know how to make one, but does that mean that it should become your default method of visualizing data? The answer, obviously, is no. And in fact, I would suggest that the data that I gathered about the sequences of gendered word pairs would actually be better represented via another type of visualization, namely a stacked area chart, which doesn't need to involve any fancy technology at all. Here's what my data for the mother-father pairing looks like in a stacked area chart. As you can see, in a stacked area chart, the data associated with one entity is stacked on top of the data associated with another entity. So, when you look at the year 1900, you can see that the total number of instances of mother and father mother is over 3,000. And of that total, the mother and father sequence, which is the pink area, makes up most of it. By 1990, however, the total number of instances of mother and father and mother has dropped to about 2,500. But more importantly, the mother and father sequence, that is, the pink area, makes up only a small part of that total. So, from this screencast, I hope that you've learned three things. First, how to use motion chart tools like Gapminder that have data preloaded into them. Second, how to create motion charts out of your own data by using Google Motion Charts. And third, an awareness of how you need to carefully choose what visualization method will work best for your data. If you have any questions, please feel free to contact me at mmorton@uwaterloo.ca.